Okay. Okay. Good enough. So we have ionic compounds, right? Up till the previous class, I think we did the properties of ionic compounds. Have we discussed that, ionic compounds have high melting points? Ionic compounds have high melting points. Ionic compounds are solid in state. Ionic compounds are solid in state, right? Why ionic compounds are ionic in state? Due to the high electrostatic forces of attraction. Yes or no? I suppose you understand that we drew the diagram something like this. That one would be cation, another would be anion. Cation, anion. Cation, anion. Cation, anion. The structure of an ionic compound would be something like this. So I suppose this is positive, this is negative, this is positive, this is negative, and so on. Yes or no? So do you understand that this positive charge? So if I draw another line of the ions, if I draw another line of the ions, I suppose you're understanding that this particular positive ion, this one, the yellow one, the negative ion. Do you see that this negative ion mark is actually surrounded by four positive ions? And these four positive ions are sort of holding the negative charge in its own position. So, which is why it is very, very difficult for the yellow negative ion to move out of the lattice. Do you remember that? We did up till this end. So, we said that there are very, very strong electrostatic forces of attraction between the cation and the anion, whereby the cation are formed by metals and anions are formed by non metals. Are you understanding my point? So, up till this point, I suppose we have done ionic compounds. Are you understanding? Have we also written this property that ionic compounds are polar in nature? Why are they polar in nature, Ma? Can you tell me? Why are they exactly? So, who do you call poles in chemistry? Who do you call poles in chemistry, Mark? Charges. So, they have a positive charge and they have a negative charge. So, thereby we say they are polar in nature. And because they're polar in nature, so I told you that in the solid state, since the ions are not free to move, so they are bad conductors of electricity. They are bad conductors of electricity. Have we discussed that? And bad conductors of electricity is also called as insulators. Okay? Bad conductors of electricity is also called as insulators. Okay? Next part that we have also discussed. I suppose we have discussed that, right, Mark? Okay. Next part is that they have high melting point. So I think all the properties we have discussed. So could you just tell me one thing, Mark, that if I have to melt them, then what would happen? If I melt an ionic compound, what would you be saying about the electrical conductivity of the ionic compound? Do you think that they would conduct electricity or do you think that they would not conduct electricity? Yeah, when they're liquid, they would conduct. Why will they conduct electricity, Mark? Because the ions can move. And the positive ions can also move. Okay, so it's not necessary that only the negative ions have to move to conduct electricity. The negative ions can move definitely. The positive ones can also move. You can have a look here. The positive ones, if you heat them, don't you think the positive will move forward, the move and the negative can also move along? I understand. I understand. So that's what I'm trying to exactly. Yeah, yeah, yeah. But exactly. But that's what I'm trying to add in here, that I'm saying that, it is either the positive charge or the negative charge. Both could move, both can conduct electricity. It's not necessary that in wires, if electrons travel, and we know that electrons are negative, so only negative charges can conduct electricity. Even the positive charges can also conduct electricity. Okay? Now, understand. So we have this ionic compound thing. Now, understand. Today, we're going to do a new property. I think, have we discussed lattice enthalpy? What is lattice energy? Exactly. So, can you tell me, if I take an example of Al2O3, Mark, and if I take an example of MgO, who do you think is a stronger ionic solid? Who do you think will have higher melting point? Can you tell me? Think on it. Think now. If you're telling me MgO, give me an answer why. No. No. Okay, tell me, Mark. If I say magnesium is atomic number 12, am I saying right? So the configuration shall be 2 8 2. So the charge of one magnesium would be what? Mg plus 2. And oxygen is atomic number 8, so configuration is 2 6. So the charge of two electrons would be, Mark, it would be minus 2. So what is the product here? If you neglect the charges, okay, don't consider the signs. For some time, don't consider the signs. Just tell me what is 2 times 2. Isn't it 4? And if I look at here, do you think that this 3 that has come here at the subscript of O, don't you think it is a valency of aluminium? And don't you think that this 2 that is coming here at the subscript of Al, don't you think it is at the valency of O? So for some time, can you just neglect the charges and let me know the product again? Exactly. So the compound where the product of the charges of the cations and anions is more, where the product of the charges of cations and anions is more. Do you understand? That compound has more force of attraction between its ions. And more force of attraction would mean what, Mark? That the ions are held very, very tightly. Yes or no? Ions are held in the lattice very tightly. Are you understanding? Very tightly. So, do you think that they would have high lattice energy? You will have to give it a lot of energy from outside to melt it. And if you will have to give it a lot of energy from outside to melt it, what would that mean, Mark? That its melting point is very, very high. Exactly. And that would also mean that it is a harder solid. Yes or no? Okay. So that is the concept. So when we are talking about the lattice energy thing, this is how you determine. So for example, Mark, if I give you this, do it. If I give you Al2O3 and if I give you Bn, can you tell me who is a stronger solid now? This is aluminium nitride. You just can't say it directly. You have to please check it. This is aluminium oxide and this is boron nitride. Yeah. Tell me. So boron's charge here would be what? Boron's atomic number is 5. Configuration is 2, 3. Nitrogen's atomic number is 7. Configuration is 2, 5. Right, Mark? So it is going to gain 3 electrons. So nitrogen would require minus 3. And boron shall acquire plus 3. So these are the charges that we have on minus 3 and plus 3. And here you know that aluminum's charge is plus 3 and oxygen's charge is minus 2. So the product here would become what, Mark? It doesn't matter. No, 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 no. I tell you. I tell you. Okay, that's how you are thinking. No, I'll tell you. How does it exactly work, Mark? See, understand. Obviously, if there are two aluminum, that's a method of neutralizing each other. But if you arrange them, isn't it? You have Al plus 3 and O minus 2. Then Al plus 3 and then O minus 2, Mark. That's how they're arranged. So when you're melting, you have to break only this one force of attraction because all the other forces of attraction are exactly the same, isn't it? The force of attraction between this blue force of attraction would also exactly be the same as this green force of attraction, would also be the same as this yellow force of attraction, isn't it? So I am not talking about the entire structure. I am talking about that you talk about a single bond. So if you feel that a single bond of Al2O3 is weaker than a single bond of boron nitride, overall definitely the overall structure would be weak na, for Al2O3. Do you understand what I'm saying? Okay, so that's how it sort of works, right? So boron nitride, the product is here. So you have to say that the melting point. The melting point is directly proportional, means that if melting point is high, that is possible only if the lattice energy is high. And when is the lattice energy high? Lattice energy is high when the product of the charges, when the product of the charges, when the product of the charges of cation and anion is high. Okay? So that is important. So first factor to decide the strength of an ionic compound is the charges of cation and anion. Are you understanding? Okay? So we did that, they have high melting point. But why do they have high melting point? I suppose you're understanding. Next concept that you have to understand is this. Now tell me, Mark, if I have KCl and if I have NaCl, now who do you think will have a higher melting point? NaCl or KCl? Oh, no. Okay, yes, very good. Why? Exactly, exactly. Okay, so this is why. So we have here what? When we are talking about KCl, so you see the charges are exactly the same. K is carrying plus 1, Cl is carrying minus 1, isn't it? NaCl, Na is carrying plus 1 and Cl is carrying minus 1, right? So the product of the charges is the same. The product of the charges is the same. But chlorine is exactly the same size. But potassium would be a bigger circle, isn't it? Potassium would be a bigger circle, right? Potassium would be a bigger circle like this. One second. Potassium would be a bigger circle like this. And sodium would be a little smaller. So thereby the force of attraction between the cation and the anion is very high. Do you understand? निखिल मेरा दरवाजा बंद कर जा. Yes, but there's a after the gaining of electrons, chlorine becomes larger and sodium becomes smaller. I'll tell you why. But do you understand the concept up till this? Yes, exactly. Hmm. And also the force of attraction on every electron of sodium is also increasing. Okay. All right. Now let me come to this point. So sometimes, Mark, now a very, very interesting fact that you're going to learn now. So up till now, this is a very, very basic amount of ionic compound that I've taught you. Now let's come to a little bit of advanced level because I suppose you can understand. Now you understand. Do you understand what is a covalent bond where there is sharing? Right, Mark? Okay. And ionic bond, we say that there is a complete transfer. When we say ionic bond, we say that there is a complete transfer of electrons from metal to non-metal. And when we talk of a covalent bond, I hope you're understanding it is a sharing of electrons, right, Mark? Between two non-metals, right? Now understand. But you write down a very, very important line, Mark. It says that no bond is perfectly ionic, no bond is perfectly ionic or perfectly covalent. No bond is exactly. So no bond is perfectly ionic or perfectly covalent. Do you understand my point? So every covalent bond will have an ion. Exactly. But there are, yes, but there are perfectly covalent bonds. There are. Like Cl2 is a perfectly covalent bond. It does not have any ionic character when the same types of atoms. Yes. Okay. So what is this concept and how do we determine the basic concept? Understand. So we will say here that every covalent bond will have some ionic character. Okay. Every covalent bond will have exactly. Yeah. Exactly. So due to the difference of the electronegativities. Due to the difference of the electronegativities. Okay. Of two atoms. But every ionic bond also have some covalent property, but not sometime. There is a rule behind that. So we'll decide today. So every ionic bond will have some covalent character, which is determined by Fajan's rule. Okay. So for covalent compounds having an ionic character, we decided with the help of electronegativities. Okay. We decided with the help of electronegativities. And every ionic bond having some covalent character, we determine which is determined by Fajan's rule, which is determined by Fajan's rule. Right, Mark? Do you understand the point? Tell me. Okay. So now what is this? Just understand. So when we are talking about the Fajan's rule, it talks about two concepts. One is called polarizing power and one is called as a polarizability. One is called as the polarizing power, and one is called as the polarizability. Okay, so write down. Very, very important concept. Have you written it down up till this point? So always understand we study Fajan's rule only for the ionic compounds mark. Okay, we study Fajan's rule only for the ionic compounds. And for covalent bonds, we do not study a rule, we just study the electronegativity difference. Are you understanding, Mark? Now, so under Fajan's rule, we have to study two concepts. Under Fajan's rule, we have to study two concepts. One is polarizing power of cation and polarizability of an ion. Okay, Mark? And one more property about ionic compounds that ion. Yeah, yeah. I'm coming to this. It's a deep concept. Now listen to me. I don't know if you've done this before or not. Have you done this ever? Have you heard of the names? Polarizing power. Yeah, yeah, yeah. Okay, okay. It's a new concept for you. I know that. Write it down. So ionic compounds are non-directional. I will teach you so much of ionic compounds, Mark, that up till university level, you will know everything about ionic compounds. Okay. So ionic compounds are called as non-directional compounds. Okay. Non-directional means what, Mark? Do you understand? When we talk about covalent compounds, I suppose you know that CH4, there are four covalent bonds. And these four covalent bonds, Mark, they have a specific direction that they have to be at this 109 degrees angle and they have to acquire a tetrahedral shape, isn't it? They have to acquire this tetrahedral shape because the bond angle is 109. So we say that, the covalent bonds are directional. The covalent bonds are directional. Do you understand my point? But ionic compounds is like exactly. So if you have a cation right here, there is a possibility that the anion might attract from this side, or the same anion might come from this side, and the same anion might then come from this side. So there is no specific direction of the anion to approach the cation. Are you understanding? Okay, so that's what we have here in the ionic compounds. That it is a mere force of attraction. So no matter from where all the entire 360 degrees space is available for the anions or cations to approach each other. So the anion could approach the cation from any direction, right, Mark? Do you understand? So this is the concept, right? So this was one point that I had to discuss with you. Now understand. Now, polarizing power, Mark, we always discuss for that of the cation. Now, understand. Let's take an example, Mark. We have Na, and it could be any metal atom because metals loses electrons to form cation, right? So, what do we have in here, Mark? Can you say that the atomic number of sodium is 11? That would mean 11 protons and it would also have 11 electrons, right, Mark? So you rightly said that the atomic configuration would be 281 and there is a nucleus and there are two electrons in the innermost shell and then there are eight electrons, Mark. And then you also know that in the outermost shell, which is the valence shell, there is one electron. Exactly. And when you give it some amount of heat, that electron's kinetic energy, tell me, increases or decreases? Increases and it starts moving faster And when it moves faster and faster and faster, don't you think it experiences an outward force and it breaks off the force of attraction, the inner force of attraction? Isn't it? It breaks off the inner forces of attraction and it loses. Yeah. Now, the point is, listen to me. Listen, no, just discuss cation today. Cation is very important. Okay, you will not understand the concept unless and until you listen. Now, see. So we have 11 protons now because nothing has gone from the nucleus. We know this, right? So after losing electrons, Mark, so could you say that, ma'am, when 11 electrons are being attracted by 11 protons in a neutral atom. So you are understanding one important point here that, ma'am, the sodium atom has lost one shell. That you know already, isn't it, Mark? But also, do I say that, there are 11 electrons in the neutral atom? And for those 11 electrons, there are 11 protons in the nucleus. Do you understand? Yes or no? What should I say? That to attract 11 electrons, there are exactly. So do you understand? Exactly. So every one electron will thereby be attracted by one proton. 11 over 11. Unitary method, Mark. A cation. So now there are 10 electrons, but they are getting attracted by 11 protons. Yes, that's what I'm saying. So do you understand that now every electron will be attracted by 11 over 10 protons? So don't you think that exactly 1/11th of an extra proton? Because for every one electron there is one proton, but that one extra proton that is left in the nucleus will divide its force on the rim with some amount of force. Yeah. So 1/10th force it provides to the remaining electrons. So the decrease in the size of the atom. One second, Mark. हम्म नहीं कुछ नहीं टेस्ट नहीं टेस्ट देके चला गया मैं उसको पढ़ाऊँ नहीं आगे right Mark? So what is going to happen, just tell me that these electrons their size would decrease, Mark. The size of the atom would decrease in what ways, tell me? The size of the atom would decrease in what ways, tell me? One, due to the loss of the shell, and secondly, due to increased attraction on the remaining electrons, right, Mark? Are you understanding my point? Due to the increased attraction of nucleus on the remaining electrons, right or not, Mark? Am I audible? Am I audible, Mark? So I hope you're understanding that the size is decreasing due to two reasons. One is the increased attraction, and one is a loss. Yes, exactly. That means yes, correct, very correct. So do you understand that normal size decrease is okay, but it would decrease and it would shrink even more. So the shell, which is actually the black shell, it will come to the position of this blue shell. The nucleus will pull it closer. Do you understand? So these electrons, which were in the black shell earlier, will now be pulled closer. So this would be the new position of the black shell, which is at the blue shell now. Okay. So can I also say one more thing, that the positive force of attraction of the nucleus is now reaching outside the atom to a greater extent. Do you understand my point? The nucleus force of attraction is reaching outside of the atom to a greater extent. Do you understand my point? Now, Mark. So now you have to understand that now the cation is holding the electrons tightly, and thereby it cannot lose further. So once it has become stable after losing, like 281 loses 1, becomes stable, it will not be able to donate electrons further. And a cation holds its electrons very, very tightly. And also, the cation is in a situation to, whosoever electron which comes in the vicinity of this particular cation, that electron here, this example, this electron is in the vicinity of this cation now. So this electron will also experience a lot of attraction, because the nucleus is not just sending its attraction to its inner electrons and the valence electrons, it is also sending the attraction to all its surroundings. So whichever electron comes in its vicinity, that electron also experiences some force of attraction, Mark. Are you understanding? Okay. Now understand. Now understand. Very, very important point. So two things you have understood. So statement that they gave you is that the cation is smaller than its parent atom. This statement you will find in books. Cation is smaller than its parent atom. So will you be able to explain it now? There are two reasons: loss of shell, okay, and increase force of attraction on the remaining electrons. And you explain it by this method. Let's suppose there are 11 protons attracting 11 electrons. So for one electron, one proton. After losing, for one electron, 1.1 proton per electron. Next. Next we have next we have the anion. Okay, I'm coming to this concept, Mark. It's a very, very important concept. Just please be with me. Anions are what? Anions are formed by the gain of electrons, Mark. Okay. So gain of electrons by an atom forms anions. Yeah, exactly. So it's like this kind of situation that you invited like four friends on your birthday party. The cation. Do you understand this part now? So can I just simply quickly move on to this fact that the nucleus, if it has 17 protons, so we were expecting that two electrons in the K shell, and then eight electrons in the L shell, and another seven electrons in the green shell, which is going to be my valence shell, KLM shell. Yes or no, Mark? And now when this extra electron joins in the valence shell, so it is 287, it wants to gain one, it gets some from surroundings. So now there is this extra electron here. So what do we say? When it was neutral, there was 17 electrons were being attracted by 17 protons, Mark. So one electron was attracted by one proton, because it would be 17 protons over 17 electrons. Yes, 1 by 18 less. Now when it become exactly, when it is forming an anion, so there are 18 electrons, and they are being attracted by 17 protons, because nothing is being lost from the nucleus. So one electron would be attracted by 17 over 18. Do you understand how you're supposed to write down whenever you're asked? So you will have 17 divided by 18. That would be 0.94 944 bar protons. That means one electron is experiencing a force of less than one proton. So this green shell will not remain at its position. It would expand. It would come at this red shell's position. Yes. Now, Mark, the point is, can I say that, once once the atom converts into its anion, can I say that the nucleus is not holding or nucleus is loosely holding the electrons? Nucleus is holding. Exactly. Is holding the electrons loosely. And now could you understand this point that if I say there is p minus 3, so phosphorus was atomic number 15, 285. So initially we had 15 electrons being attracted by 15 protons. So for every one electron we had one proton, but after it gained 3 electrons are becoming 18 electrons, but they are being attracted by. Exactly. So 18 electrons are being attracted by 15 protons. So it would become 15 over 18 protons. How much is that? It is way more less than, because now the nucleus has to attract 3 extra electrons. So what it would do? It would remove the forces of attraction from the electrons in order to attract the 3 new electrons. Are you understanding? Yes, Mark. So it shall be 0. Exactly. So the word that you find in books, it says that the electron cloud is is expands and is loosely held when when the negative charge on the anion increases. Does this make sense to you? When the negative charge on the anion. Right, Mark? So what do we have in here? Just understand. So can I say that the electron cloud is loosely held and expand? The electron clouds expands and is loosely held by its nucleus. Loosely held by its nucleus. Yes or no? Okay, now. Now, Mark, understand. Now, I told you the two terms, they were polarizing power and the polarizability. What are these two terms? Just understand. No, 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 no. Now understand. So when I just said that, no ionic bond is perfectly ionic, okay? Because what is an ionic bond? The ionic bond is that, we have sodium, and sodium has one valence electrons, and we have chlorine, which has seven valence electrons, right, Mark? So we know that sodium 100% loses electrons to chlorine because chlorine gains one electron from sodium, isn't it? You put sodium and chlorine in a beaker and you heat them. So you're heating sodium so that it gains energy, and that valence electron gains energy, breaks the force of attraction, reaches to chlorine. isn't it? So when Na loses electrons, do you think that Na shall become Na plus cation and will hold its electrons tightly? And anion Cl will become, so let me draw it here. So I would say Na will become Na plus 1 and will become a cation now and will have a smaller size. And Cl will become bigger and will have a bigger size and it shall become Cl negative. Are you understanding? So do you understand that the moment chloride, now this is chloride, okay? When it becomes an ion, it becomes chloride. So this chloride is an ion and it is bigger in size than chlorine. Yes or no? Chloride is bigger in size than chlorine. So can I say that the chlorine is not holding its electrons tightly? The chlorine's electrons are actually lying here, very far off, right? But the sodium's electron are lying here. The sodium's electrons are lying here in this green area. So I think you understand that sodium is holding its electrons way more tightly than chlorine. But do you understand that the sodium atom, this sodium atom, because it is smaller in size, so it is not just attracting. So see, understand, because it acquires a positive charge and chlorine acquires a negative charge. Yeah. So this sodium ion, because it is holding its electrons tightly, but its force of attraction is not just reaching its own electrons, its force of attraction is also reaching the chloride ion's electron, these electrons here. And you know what would happen because of the sodium's force of attraction? That no matter how much sodium has lost electrons to chlorine, when they combine, when they join because of the attraction here, because sodium carries a positive charge and chlorine carries a negative charge, this group, this entire electron cloud mark will shift entirely towards here. All the electron cloud will shift exactly here. From here, from here, it shifts here. Do you understand my point? And why is that happening? Because the nucleus is unable to hold the electrons tightly. Yes. So you know what is happening? This electron cloud, don't you think that this has come exactly in between the nuclei of sodium and chloride? Isn't it? And the electrons residing just in between the two nuclei, don't you think it is looking like a covalent bond? So understand one thing. Was it easier? Was it easier for sodium to pull chloride's electrons here? Why? Because chlorine was bigger in size. So I would say sodium is polarizing the chloride. So sodium has a polarizing power. Do you understand? Polarizing power would mean what? That if you look at sodium, if you look at chlorine, don't you think that within the chlorine or within the chloride ion, the entire, listen, the entire electron density is here. So if I just consider the chloride ion, don't you think that this n has become little more negative and this n has become less negative? That means we can say it has sort of slightly positive charge. Should I come again? Are you understanding? So, do you understand that the sodium ion is trying to create a difference of the electron density within the ion itself? So, don't you think that I would say it is easily polarizable. So, it is polarizability, that how easily it is easy to shift the entire electron cloud of chloride from one end to the other end. Are you understanding? Okay, so it would be the polarizability of the anion. Are you understanding my point? So now do you understand? So polarizing power, because who is pulling the electrons? Who is pulling the electrons? The cation. And why aren't we saying that the anions would be pulling the electrons? Because anions are not even able to hold their own electrons because of their bigger size. How would they pull the electrons of sodium? Yes or no? But cations would be pulling the electrons of the anions, and which is why the entire electron cloud, which is actually all around the nucleus, has been pulled exactly. No, no, never. There always has to be a slight difference, and 99% times cations would be smaller and anions would be bigger, unless and until it's a very very weird shape like calcium fluoride. So yeah, so calcium fluoride, even after losing electrons, fluorine would still be smaller. No, no, no. Even then, in that situation, we would. That's what I'm saying. That's a very rare case. Do you understand? In that situation, what would happen? Fluorine will pull the electrons of calcium, but the process would remain the same. The electrons would exactly come in the center of the two nuclei, and this ionic compound would not be a sort of 100% ionic compound because the electrons are residing right in the center. So it is acquiring some sort of covalent character, isn't it? So now do you understand that that all ionic compounds are not 100% ionic? They have a partial covalent character too. So what does Fajan's rule state? Now tell me. So Fajan's rule basically talks about what? Yeah, it talks about the polarizing. It is talking about the polarizing power of the cation. Now there are points about it. Now just you will understand it now. So the polarizing power of cations. Now, Mark, be with me and tell me if you agree with this or not. It says, it says, smaller the cation, tell me, smaller the cation, more or less will its polarizing power be? More, because it is holding its electrons tightly and it is also sending its force of attraction outside the ion to a greater extent. So it is going to pull the electrons of the anions more tightly, and smaller the anions, more is the polarizing power. Yes or no? Secondly, can I say more the positive charge on the cation, more the positive charge on, exactly, more the positive charge on the cation, that means it has lost more electrons. If it has lost more electrons, that would mean the size is very small. The size of cation is small, which is why it holds its electrons even more tightly, and thereby, again, its polarizing power would be high. So you tell me Fe plus 2 and Fe plus 3, Mark, who do you think will have more polarizing power? Exactly. So you know how the question is put up? The question is like this. It says out of FeCl2, yeah, out of this, which is more covalent. And people will get confused that, what kind of question is this? Because Fe is a metal and chlorine is a non-metal. So bond between a metal and non-metal. No, FeCl3. No, it will be more covalent. It's not about losing bonds. Understand? That's what I'm trying to explain you. See, listen to me. Exactly. It's about the electrons being in the center of the two nuclei. And when will the electrons be in the center of the two nuclei? When the nucleus of the cation will pull them in the center. And which nucleus will, or which ion will pull the electrons in the center to a more extent? Fe plus 2 or Fe plus 3? Definitely Fe plus 3 because it is smaller in size. Yes or no, Mark? So do you understand now that if the anions are same, do you look in this structure? The chloride is exactly the same in both of them. FeCl2 is basically made up of Fe plus 2 and Cl minus 1. And Fe plus 3 is also made up of Fe plus 3 and Cl minus 1. Are you understanding? So what do we have in here? Tell me. Exactly. Cl minus is same in both of them. But whose electrons do you think the chloride's electrons would be pulled strongly by which cation? Don't you think it should be Fe plus 3? Exactly. So if Fe plus 3 is going to pull the electrons in the center, so Fe plus 3, definitely it's a bond between a metal and non-metal, but it will still have a little bit more amount of covalent character than FeCl2. Do you understand my point? Is it a new concept for you? Are you learning something new, Mark? Okay, I'm also happy with this. So this is the concept, right, Mark? Second part. So could I just put it in this way that more the polarizing power, more is the covalent character. More the polarizing power, more is the covalent character. Are you understanding my point? Understood? Now, next we'll discuss about the anions. Tell me. So you tell me if I have KCl, if I have KBr, and if I have Ki, the cation in all of them is same, isn't it? The cation would be all of them would be having K plus Cl minus. Now understand. So cation remains the same size. This is cation. Exactly. So whose electrons do you think is exactly? So whose electrons would be possible for us to bring them in the center? Iodine. So if I'm bringing the electrons of iodine exactly in the center, do you understand that potassium is itself capable of pulling the iodine's electrons more in the center? So do you think that out of KCl and out of KBr and out of Ki, obviously all of them are bond between cation and anion, but Ki would be more covalent and than KBr and than KCl. So I would write it like this, that according to Fajan's rule, I negative is bigger in size. According to Fajan's rule, as per but so it yeah, yes, yes, it increases exactly now. So now are you able to put it in the periodic table concept now? So acha, one more thing, Mark, have I discussed exactly, that's good. Tell me one more thing, have I that's not a problem. Just no, no, yeah, that's fine. That's fine. So nobody can, totally learn 100% elements. There are very few people who could do that because you have to do a lot of things. Just tell me one thing, Mark. Have I discussed with you the concept of charge density? Have I discussed with you? You seeing it on the YouTube, that's a different concept for me. But have I explained it to you my way? Okay, fine. I'll discuss. So we have I negative is a bigger anion So it has more polarizability. More polarizability would mean that it is not holding its electrons tightly. So the cation, yeah, so the cation could pull it. Exactly, exactly. Very good. So cation, hmm, hmm, yes. No, your concept is right, but you're saying it opposite. Protons have less charge density than electrons. Yes, 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 yes. You understand the concept correctly. Very good. Yes, yes, true, true. But do you can you explain it to me with regards to atom? Okay, with the subatomic particles you've explained me very good. But can you explain that concept to me with regards to this mark, the atoms? Sorry? Oh, yes, 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 yes. Okay, 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 okay. Understood. Yes. So how would you put in your answer? You will say I negative is an anion bigger, so it has more polarizability. Mm, yes, exactly. Because sodium or whatever the cation is trying to pull the electrons, and since its nucleus is not holding the electrons tightly, so the electron density would be accumulated just in between the two nuclei. You have to write down these lines. The yeah. So the electron density is accumulated in the center of two nuclei, isn't it, Mark? So this is the second half of your ionic bonds. Hmm. So it holds the electrons tightly, doesn't allow because it's least covalent. Yes. Do you understand the concept now? So what is new for today's class is Fajan's rule, but it is still half of the ionic bond. So the first class that we did for the ionic bonds, we learned up till now that there is a cation, there is an anion. Cation is formed by metal. Metal loses electrons. Non-metals gain. Non-metals form anions. Cations form cations and anions attract by the forces of because they lose electrons. Yeah. Okay. So when they lose, yeah. Hmm. No, but I'll tell you the real difference. There is no difference at all. It's just how we perceive it. We'll discuss it when I'll do the concepts with you anyway. I understand you see a lot of videos and then you know a lot of things, which is great, but I'll give them a finishing touch. Don't worry. So yeah, I'll see you next would be I think 28th. 28th would be the last Wednesday of this year, Mark. So last class of this year, I'll see you. Okay. All right. Bye. Okay. One more thing. Oh, listen to me. Listen to me. One more thing. I think 28th would be my exam. So on 28th also I won't be doing class at the same time because I had an exam early in the morning today. So that's why I couldn't do class at 3. So there's a government exam here in India. So we have these exams for teaching. So till now I have been freelancing and schools and but there is a government exam for which we have an exam. So it's a series of exams that you have to give one after the other. So that I have on 28th. So most probably if we could schedule it like one day before or one day after or on 28th in the evening, if that will be great for you from me. Because I don't want to cancel the class. I just want to reschedule it. Or if you're not available, we can do it next year. That's fine. Yeah, yeah. Only for this week and the next week is this. Okay. No, no, any time. 28th is Wednesday again. Yes, Wednesdays is one of my hectic days in classes, but yeah, 7 to 8 is always. No, I can do Tuesdays. I don't have a exam on Tuesday. So if you want, I can spare 1 hour on Tuesday. 3 to 4 same time. I can do it on Tuesday if that's working for you. What? My class? Should I teach you more? I know that I cannot satiate you. No, I can do that because I can teach you as much as you want because you get me what I teach. Really, I'm telling you. And I'm not short of the content. Don't worry about it. So it's like you have to understand. Yeah, ma'am, you can just let me know whatever time suits you. And yes, 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 yes. My exam, my exam is again tomorrow is also one of my exams, but I choose to do the class today. So 23rd, 26th, 28th, and 30 is my exam. What is the time at your place now? What is your time right now at your place? Okay. Okay, so you are 3.5 hours behind India. Fine, I'll schedule accordingly, ma'am. Sure. We can do it on Thursday. No problem. Thursday is better. Yes, ma'am. All right, bye. Thank you. Bye.